Waiting on the recording to start. Good. So we're on for today. We have nested if statement, right? Last week we started off by taking a look at the nested if statement, which was like an if statement inside of an if statement. And in general, we're going to, this nesting is a concept that we are going to be working with moving forward. What it is that it is putting one control structure inside of another control structure. Elon, you have a question?
No, my bad, sir. I clicked by mistake.
Oh, okay. All right. All right. So as I said, the nesting was a concept of putting in an if statement inside of an if statement. Okay, and we took a look at one of the biggest programs that we write so far, like a huge algorithm. We say we want to write an algorithm that allows a user to enter a date in a specific format. Okay, and we had a range of dates. And we kind of walked through all of the different possibilities in terms of thinking through towards a solution. Okay, so we have where depending on the month, we could choose the amount of days and check and see whether or not a given amount of days inside of a given month was valid. And then for the month of February, we had to consider the year in addition to the days, because certain years had certain amounts of days. So what we did is that we set up rules. And then we express these rules as an algorithm. So we allowed for the variables to be declared, and then we said we want to enter the date, and we want to perform if statements, if statement to check, and only where the year is bigger than 0 and the month is between 1 or 12 inclusive could we check even further. Otherwise, right off the bat, the date would be invalid. And then we have the for the months before the 69th, the 11th month, we check to see if the day is between 1 and 31 inclusive. If it is that it was the 1st, 3rd, 5th, 7th, 8th, 10th, or 12th month, we check to see if it was in between 1 and 31 inclusive. If the month was 2, if it was the 2nd month, then we had to make sure that it was a leap year before we could check for 29 days. So what did we say? We said, okay, once you're inside of this else here, which meant that the month was 2, then you had that you had to have a leap year being one of 2 conditions. And those 2 conditions are 2 things have to hold true in one condition and 2 things have to hold true in another. But it's one or the other. It's either that the year is divisible by 400 and 100, or is it that the year is divisible by 4 and not divisible by 100? Okay? And so what this first rule was that it's a century year that is divisible by 400. Or is it a non-century year that is divisible by 4? And you had, of course, if it is that is one of those 2, then it's a valid date. Otherwise, it's an invalid date. And if it's not a century year that's divisible by 400, or if it's not a non-century year divisible by 4, then it should be between 1 to 28 in terms of days. And we tested it with a whole bunch of dates, and we saw that it held out. Okay. And then we kind of had an introduction to looping or iteration. And we spoke about bounded and unbounded iteration. And for bounded iteration, we identified that we had a value given beforehand in terms of the amount of times a given instruction should be repeated. Let me ask a question. Am I coming in poorly? Is my internet connection? Does it seem like it's bad?
Not sir, fine.
I'll say it good. No, sir.
Oh, okay.
Completely fine.
Okay, good. All right.
Wait, see, I don't know, but like I find you coming out a little broken up and stuff at times, you know.
Okay. All right. Well, that might, I don't know. It could be on your side if everybody else said that I'm coming in fine. All right. But I guess this is where the recording will come into play. If it was like the majority of people, I might have get up and check more out or something. So, but I think if it's just one person, then you might have to restart your auto. All right, because actually, though, incoming data is kind of slow for me, but I think I might have, my wife might be using the internet, and my daughter might be using it soon as well. So in terms of internet usage on a Tuesday morning, things are a little demanding for my household. Anyway, let's move forward. We have a for loop, and we say with respect to this for loop, we have to give a start value for a particular counter, a stop value, and an increment. And that for loop then tells us that we have to start at a particular point and end at a particular point. And do an instruction or a set of instructions, do an instruction or a set of instructions when we loop. And for each loop, that instruction is done. Now, this instruction could be, of course, changed according to if statements inside of the loop, etc. Right? But we just did a simple example. So we wanted to display values from 1 to 100. We wrote a loop. You only need one print statement. You only need one print statement to get 100 values printed out. What you have inside of, around that print statement is that you have a for control statement that says do this print statement 100 times. And you set it up so that the value in the variable, the counter variable, is printed out so that you change those values. Everybody with me? Yeah?
Yes, sir.
Right? But the key characteristic of a bounded iterative statement is that it has a defined start value and a defined stop value. Whereas for an unbounded statement, in unbounded iteration, we do not know when the criteria will be fulfilled. So we have to wait until a specific criteria can no longer be met. And that criteria could no longer be met on the first iteration. It could be no longer be met on the 10,000th iteration. But all we know is that we cannot say for sure how many iterations it would take. And we did an example in class, right? We told somebody to clap their hand X amount of times, and that student clapped their hands X amount of times. Whereas we told somebody else, stop waving your hand when you feel like it. And she took down her hand almost immediately, right? So as we identified, she could have, decided, I wanted to wave for 10 seconds more. I wanted to wave for 20 seconds more. The thing is, I can't control how long she wanted to wave. So that instruction that I gave was an unbounded instruction. As opposed, right, Nissa?
Sorry, sir.
Okay, no problem. All right, so we have the two loops, and we have two loops that fall under the unbounded category. And the first loop is a while loop, and the second loop is a do while loop. And the first loop is a while loop, and it executes instructions 0 or more times. And the second loop is a do while loop. It executes instructions at least once, but then it could do it more times. So in the case of the while loop allows me to check to see if the condition is true before doing any instruction. And before doing any instruction, I could not satisfy that condition. What is going to happen? 0 instructions will get executed. Whereas with the do while loop, the instruction is done once, and then the condition is checked to see whether or not we should continue with looping. You all with me here?
Yes.
All right, cool. All right, so this is where we reached up to the last class. Just give me 2 seconds. I have to go set my thought up for a class. And then when I come back, we're going to go a little more into practicing these loops. Okay, so we'll do an example based on a question, and then we will more than one example based on some questions, and then I will give you all some even harder questions to attempt on your own. Okay, so we're going to have some fun today. The fun begins. All right. Nobody looks like they're excited for the fun. Don't worry about it. All right, so I'll be right back. Okay. All right. So I'm back here. We're going to talk about some loops. Okay. So again, just to some of you who were with me in the session last night, I'm going to do an exercise very similar to the exercise that we attempted last night, which is a exercise that focuses on just seeing our understanding of loops. But then I want to today, hopefully, we're going to move beyond just doing simple loops with if statements in it, And we hopefully by the end of the class, we could get to like nested loops as well. Okay. So we have some exercises with respect to loops, and I want to start off by just testing your understanding with a loop. So we're going to take a look at a problem, and the problem is, and let me preface this by asking everybody at least understands the everybody at least understands the concepts that I shared just now, right? Between what we did last class to today. Yes? So we're reading a loop and we want to find the sum of numbers from 10 to 100. Anybody, you could have stopped me. If it is that you didn't understand, then you could say, sir, I needed to go over something. Anybody like that before we go into this? No. All right. Nobody says no. Everybody just stays quiet. All right. So we have we want to find the sum of numbers from 10 to 100. So we have some instructions here. And, you know, it's a counting loop. We have sum being equal to 0. We say counter equal 10 to 100, step 15. Sum is equal to counter, loop and counter. Sum of the numbers equal to sum. What would we have to change here, right? This is just basic, just understand. Anybody want to tell me, well, what's wrong with what I have here in terms of the numbers from 1 to 100, according to how we understand this? Where am I going wrong with wanting to sum up all the numbers from 10 to 100?
So the part where sum is equal to counter, sorry. The part where sum is equal to counter.
Okay, so we identify an error here. What should it be?
Should be sum is equal to sum plus counter.
Right, so counter, right, plus sum. Anything else?
So that for the increment, it's in step 15.
Good. So the increment should be what?
Step 1.
Step 1. So we had too big an increment. Okay, so this loop wasn't going anywhere prior to these changes that we made. Now we could say, okay, the loop, we have the variable counter, 10 to 100, step 1. It means now start from 10, go up to 100, and each time that we reach to the loop end, we increment the counter by 1 instead of 15. Okay, the book that I have here represents the code a little differently from how I write it, but I mean, again, it's pseudocode. Everybody's pseudocode is a little different. So if it is that I had to write this, of course, I would have used the statement for counter is equal to 10 to 100, step 1. And then, of course, we would put sum is equal to sum plus counter. Right, and then we have N4. And we know that on the N4, the step 1 gets performed. Agreed? Everybody agree? Everybody with me? Yeah?
Yes.
All right. All right. So, all right. So I'm going to ask us now to do a question together, right? An algorithm that calculate the average of the average grade between 1 to 100 for members of a class. The amount of students that the grade average will be calculated for is unknown. But the grades, the grade entry, will stop once a value less than 0 is entered. Okay? Once a value less than 0 is entered, the grade entry will stop. Or let me say once the value -1 is entered. So this is another question that we have here. We're going to do this together. We want to calculate the average grade between 1 to 100, not 1,000. Sorry, right? So a grade is between 1 to 100. That's students' grades there. For members of a class, we don't know how many students are in the class. But what we do know is that the grade average is going to be calculated as long as we collect all the grades. What do we need to solve this algorithm? What do we need to solve this algorithm? First of all, first questions first. What kind of iteration does this solution require?
A while loop.
A while loop. I feel like a while loop could work for this solution. So we know that we're using unbounded iteration. What variables do we need? So we could always start off by identifying the variables that we need. All right, and remember that we spoke about it last class. Every program that we write goes from input to processing to output. Okay, so we look at what values we have to put in. Don't even start to worry about what you're doing with those values until you understand what you need to input into the system. Okay? Once you have all of the variables that you need, or you have a fair idea, because we could always go back and add variables to the variable listing. Then you have your processing, which is what steps do I take towards getting to my answer? And then the output is just simply presenting your answer. Okay? Right. Nobody worried about programming, right? Nobody worried about this. We taking our time. You know, I think we're doing well. I honestly find that, you know, as a class, you guys are progressing well. All right. All we need is a little practice, and we doing that. Every class we're getting better and better. Okay. And remember, I always say, if it is that you as an individual, you feel like if you are not where you're supposed to be or not where the class is, I would appreciate if you tell me at this point. This point being whatever point that you feel it is that you are not up to scratch. Because I don't want you to feel like if you should try and catch up and you're not catching up and you're actually falling behind during all that time where I could have been helping you catch up. Okay? And then you come to me in like February or March and say, we looking at doing the IA, and you saying to me, sir, you lose me at looping. All right, because at that point it's going to be really difficult for us to catch up. So, you know, you don't have to say it in class. You could just always just message me, right? Teams chat is always open. You might can get an immediate reply, but you get a reply by the next day. And we could see how we could work with each other from there. Okay. So I see some people already zooming ahead. All right. Remember, this is just the test question that we're doing here, the one we're walking through with each other. So we have an algorithm that calculates the grades. What variables might we need? Every grade is between 1 and 100 inclusive. So a grade is 1 to 100. A grade might be an integer. Okay, so an integer grade. What is it that we want to get for the average as an output here? We want to get an average. An average is typically a what type of number?
A real.
A real number. Okay, so we have real average. And to get the average, we have to have a sum of all the grades. And we also have to have a count of how many grades were entered, not so? Right? Because most averages is just simply a sum divided by a count. Or all averages is a sum divided by a count, right? That's what an average is. So we can say sum, but we have to make sure that sum is initialized to 0. Why is that? That is because sum is an accumulation. And if we are accumulating a value, then an accumulation of a value is, it has to start from 0. We must know our starting point. The same for count as well. Count is equal to 0. We must start from 0. The count must start from 0. So as long as we get one valid entry, then count will go up to 1. As long as we get a valid grade, then sum will go up by whatever that valid grade is. Agreed? Okay. So where do we go next from here? We kind of identify variables that we need. What is the next thing that we do? The next thing that we do is that we identify our inputs. Jarrell, that's what you was going to say. Okay, I'm not hearing Jarrell at all. Yeah. I see like if your icon is like telling you that you're trying to speak, but we're not getting any audio. I don't know if anybody else is getting it.
Am I now, sir?
Yeah, Jarrell.
Yes, I was going to say input and condition.
Right. So you're on the same page as the rest of us. So the first thing that we do is that we can prompt, we could say print, please enter a grade. And we could say what? We could say input grade. And you know, I personally feel like if this this should have been a do while loop, but we go in with a while loop for now. And the reason that I think that there should have been a do while loop is because of this stipulation that the grade must be validated in a certain way. And regardless of how many times you enter your values, your grade should have been, you need to enter at least one grade. You understand why I'm saying that? Okay, so in this case, I feel like a do while would have been more appropriate because I think that in all cases, we would have said do, please enter a grade and take the grade in. Now we could start to check to see if that grade is a valid grade or not. All right, we could check to see if that grade is a valid grade or not. So Once we take that grade, we have to check and see if that grade falls within the range of being of being such that it should enter into the sum of grades, and the count should go up. So we could check for that. We could check for that using an if statement. Because now once we have a grade, we have some decisions to make. Our decision is it a valid grade? We do a task. If it's an invalid grade, we do a task. If it's the grade that signifies that we should stop entering, we might need to do a task as well. Okay? So let's see what we do. Let's say input grade. Let's see what we do if it's a valid grade. How do we specify that it's a valid grade? Kyra, are you there?
Yes, sir.
Okay. So what do we have to state as a statement, as a logical statement to identify if this grade is valid? We identify that that's between 1 and 100. How would we say it as a statement?
Well, if grade is more than or equal to 1 and and less than or equal to 100.
Right. So you have less than or equal to 100, but you thanks. And this is something that we do as programmers very early on. Remember, we have to make complete statements. So grade is greater than or equal to 1, but what is less than or equal to 100?
And grade?
Right. So grade. So we have to put grade. We have to have something on both sides of the operator. So now that we have this, we have a complete statement. So if grade is 70, let's just test this out. If grade was entered to be 70, 70 is greater than or equal to 1. So this is true. 70 is less than or equal to 100. This is also true. We can do what's in this if statement. If grade is equal, let's say we enter 165 as grade. If grade is greater than or equal to 1, this is true. And if grade is less than or equal to 100, this is false. We are joined by an and. And requires both to be true for us to do the instructions that would be under the control of this if statement. So true and false will give us false. We cannot do whatever is inside of that if statement. Everybody's with me? Right? Do not get so concerned about making your whole solution at this point that you don't stop while you're developing and think through the answer for the thing that is immediately in front of you. Once you do this that I'm doing right now, and you think through, okay, I'm dealing with this scenario, and then I know the other scenario, and I know the other scenario. Think about what we did just now. We said we identified that we had 3 scenarios. The scenario was we had a valid grade. The scenario was that we had an invalid grade. And the scenario was that we had a grade value that would want us to stop entering values. Now we said, let's deal with making sure we could say what to do for a valid grade. So that's where our focus is at. Once we finish this, then we will go back and check the scenario for an invalid grade. And then what to do in the case of an invalid grade. And then we will check and see what to do in the case of, if the grade was not, if we get that stop value grade, that -1, okay? So right now we're just focusing on this first part here. We say if grade is greater than or equal to 1 and grade is less than or equal to 100, what do we want to do? This is a valid grade. once I'm inside here, I know I have a valid grade. Nissa,
Yes, sir.
what do we want to do if we have a valid grade?
You want to allow them to enter it because it's valid, right?
But we already entered the grade above here. What we did was that we validated the grade. So if we have a valid grade, then it means that we should
Add it to the sum so you could calculate the average.
All right, good. Thank you. Thank you, Nissa. All right. So once we know that the grade is valid, we do two things. We say sum is equal to sum plus grade. And again, I said that this is an accumulation. What is on the right-hand side gets done before the assignment. So your equal sign, as we spoke about before, is your assignment operator. And you could use it in like you're saying, B is equal to 5. What it means is take the value of 5 and put it in the variable B. But if it is that I have an operation being done like 6 plus 7 is equal to B, then it means do this part first and put it into B. So B is going to be 6 plus 7, so 13 goes into B. But what if the variable itself, if I had B is equal to 8, and then I put B is equal to B plus 15. B is currently equal to 8, but then we want to do this operation first. So this one is going to get done first. B plus 15 is 8 plus 15, which is 23. So we had 15 inside of here, and now we take the value of 23. Sorry, B was originally 8, not 15. We take the value of 23, which is 8 plus 15, because B plus 15 is in here. And now we remove that 8 that was inside here, and we will ultimately end up with 23. Everybody is with me? Okay? So don't get too worried about this. This sum plus grade here, you do this part first, and then you do this part second. Okay? So sum is equal to sum plus grade, and we have to also, because we need the count of valid grades, we say count is equal to count plus 1. This is what I had so far on the paper. I see some people writing down beforehand. When you all started scribbling, this is where you was heading? Yes, no? John, Emmanuel?
Yes. No,
Yeah? All right. Okay, yep. So, right. So, as it is right now, I think that that's all we have to do for a valid grade. We say else. We have more than one other scenario, so we have to have another branch, right? So let me ask Kishan.
Yes, sir.
Kishan, where are we going from here? I lost. You have to help me.
Hold on.
Okay, so we check the valid grade. So what was the next thing that we should do?
Well, after we add one to counts, then we have to accept another one. So we have to, wait, no, we'd have to,
Mm-hmm.
Okay, so if grade is this, right?
We
So
have, right,
else,
remember
then
we had three scenarios, right? We
hmm,
had valid grade, we had stop condition, and then we had invalid grade. So we
yes.
did what
So
we needed to do for valid grade.
yes. So that means
So,
next we have to give what would happen if we enter an invalid grade, so something less than 0. So we'd have to say else and if for something like that, we'd have to end the whole thing.
all right. All right. So I go in with you up until we say we have to enter the invalid grade. And I'm actually going to stop you and say, remember what I said last week about programmers always taking the laziest solution?
Yeah.
Right. So the laziest solution in this instance is that we knew what the criteria for a valid grade is. We know what the criteria for a stop condition is. And we know that if it is that we work out the criteria for those two, we don't have to put a criteria for invalid grade because anything outside of that would be an invalid grade. So I, as the good lazy programmer that I am, I would say if what? Else if grade is equal to -1 in this instance. You see where I'm going with this, Kishan?
Yeah, I see.
Okay,
But
so I worked out what the grade was, what to do if the grade was valid. Now I'm working out if the grade is on the stop condition, which is -1. I could just simply say, okay, print grade entry stopped. Okay, STOPPED. Grade entry stopped. And then I could put else here, and my else will take me to print invalid grade entered. Invalid grade entered. Mark not recorded. And then I can say end if. And then I will go down to my while. And what is my while condition for stopping? My while condition for stopping is actually the same thing as this stop condition here. So I could say while grade is unequal to -1. So maybe we could test this now with some values and see how we loop around. Okay? Everybody with me so far? We're looking like we make sense. Again, and we established last week, what we write don't have to make complete sense, eh? Or what we write should be something that makes just enough sense for us to test. And through testing, we could find out what we need to fix. Agreed?
Sir, weren't we supposed to calculate the average?
Yeah, the average could take place after the while. Or we could take it, we could have it take place here as
But
well.
what I want to know, sir, right? They said that it have to be stopped. So I wondering if they want us to output the average after they stop it, or if it's like if they stopped and the finished are different kind of instances.
All right. The amount of student that the grade average will be calculated for is unknown, but the grade entry will stop once a value of -1. You have to calculate it after the grade entry. So we could at this point, Clement, decide, okay, inside here, we could calculate the grade because once that -1 is entered, we know for sure that no more grades come in. Okay? So we could say inside here, we could say AVG is equal to sum divided by count. And I'm going to come back to here. I just have this here for the fact that you brought up this argument. Okay? So I was just going to test our structure and then we would have put in this. But let's do this now. Let's say print the average grade is AVG. Average. Hold a second, please. All right. Thanks. Sorry about that. Daughter come with a crisis. A little eraser slider thing breaks, so she needed that fixed one time. I wish I was 6 years old where the biggest issue in the world is my eraser stuff working. You know. All right. So let's go. We taking a step back and we testing. Let's enter. Let's say we have a list of grades: 30, 92, 71, and 40, and -1. So this is test set 1. This is test set 2. We'll have, for test set 2, we just have -1. And for test set 3, we'll have 132, -2, 70, and -1. Okay, so we have 3 sets of data that we tested. Let's drop a trace table. So we say grade, we say sum, we say count, we say average, and we have output. Okay, so we have 5 different categories. The first grade that we enter, so we run in, we say do, please enter a grade, we input a grade. The first grade is 30. So we enter 30. Is 30 between 1 and 100?
Yes.
Yes. Okay, so I need all you talking to me, right? The value of sum start off 0, the value of count start off 0, initialize. Agreed? Kishan?
Yeah, sir. Just taking a step back for a second. I'm sorry. So we essentially ended the while loop there when grade is not equal to -1, right? So what would stop me from entering -2 or anything lower than -1 in there? Shouldn't it be
Nothing,
like
but
when?
we have our validation here.
With the if? Okay.
Huh?
So then.
So that's why we have that as test data down here too.
Okay. All right. Cool. Thanks.
Right? So we'll see what will happen in that case. All right. But I like it. I like the fact that we're thinking about these things. Okay. I expect some rock solid SVAs. All right, but let's not jump ahead. So we have 30. We get please enter grade. I'm not putting the output for please enter grade, right? I'm just entering the grades. 30. So we say 30 is between 1 and 100. So we add that to sum. So sum right now is 30 and count is what? 1. Yes? Everybody agree with me so far?
Yes, sir.
All right, good. Right? 92. So I enter grade 92. 92 plus 30 is what? 122. And that's a valid grade, so we have 2. All right. Then we move on to the next grade, 71. 71 plus 122. Mr. Valles, you give yourself a set of hard stuff. 193. Okay, so this is 3. Am I correct in that? 122 plus 71? Yes. 193. And then we have 40. Okay, as the next value entered. 40, 193 plus 40 is what? 233. And this was the 4th. And then we have -1 entered as grade. So in this instance now, we hit here. So what is our output? We get grade entry stopped, grade stopped. And then the next thing is that we calculate the average. 233 divided by 4. 233 divided by 4. Right? 4 into 23 is 5. 3, 4 into 33 is 8.25. Would it be? So we will get that the average is 58.25. And then what happens here is that we go down. And what is grade at this point? Grade is -1. -1 in equal to -1. This statement will give us what? Is -1 in equal to -1? No, it's not. -1 is -1. So this is false. So this will make the while loop stop. Everybody with me on the first set of data that we have?
Yes, sir.
Yes, sir.
Right. Good. So I could erase some values here, right? Because I want to use back the same little thing. And it'll be in the video, so you could just rewind and take a look at the values. So let's go for the second, data set. And I foresee a problem with the second data set. Clement, I feel you seeing a problem with the second data set too. Yes?
Yes, sir.
Yes, okay. I see Jonathan, St. Bernard hand up. So Jonathan is going to tell me that the second data set is going to.
NASA, I actually had a question.
Yeah, go ahead. Go ahead, Jonathan.
It does have one thing that I don't really understand about the assignment that we did so far. The line that reads else if grade is equal to -1. I don't really understand why it is we using -1 there. If you could probably explain that, that would be appreciated.
-1 is a stop value. So we have to have a value that indicates that we do not want to enter grades anymore. So we've just picked -1 as the value that is going to say once -1 is entered, it means stop and calculate all the grades.
I see.
That's it. There's no other. You could have picked any value that is outside of the range of valid grades. Okay? Or you could have used a Boolean variable, but then you would have had to ask at the end of every grade entry, do you want to continue? And that could get a little tedious for users because you don't want to ask, please enter a grade, input your grade. Want to enter another? Please enter a grade, input your grade. Do you want another? Please enter a grade. Enter. You understand? But if the user knows that the value of -1 could be used, if the user knows that the value of -1 could be used to stop, then I could just enter my grades and knowing that once I enter -1, I'm going to get my result. And that's a common thing done in programming and computing. Okay, that you have some sort of value that indicates, well, this is the end of my list. Yes, set.
Yes, sir. I was gonna say that with this second one, you get an error.
What? Yes. What error are we going to get?
Also, because it didn't enter any grades before, sum and count would still be 0, and you can't divide 0 by 0 or anything by 0.
Exactly. So we are looking to set ourselves up in the second one for a division by 0 error. So how could we prevent that? We have to make a decision. Yes? We have to make a decision. So what decision could we make around here that would prevent a division by 0 error?
So you could just say
right?
if sum and
If
counter.
we could just use count. If count is unequal to 0, what do
Right?
we want to do? Then we want to calculate the grade. Otherwise, else
Right.
what?
No, they could print like no grades entered or something.
Print, yes, no grades were entered. So you see how we adding value to our algorithm?
Yes, sir.
We adding value to our algorithm through testing it. Because this wasn't really a consideration when we wrote it. But now we test a case that we wanted to stop immediately, and we identify that, we would have blown up the universe by dividing by 0. So the grade entered is -1. So we enter -1. -1 doesn't fall within this category at all. So we can't do anything underneath that control. We do this one. This is it. So we print grade entry stopped. And then we say, what is count? Count and sum were initialized to 0, and they're still 0. So is count unequal to 0? No, it's not. Then we have to do this else. And we say else what? Else no grades were entered. So our output is no grades entered. Make sense? Yes? No? So
Yes,
what
sir.
kind of dark witchcraft are we embarking in here? Right? It's this kind of black magic. I want to do another subject instead. Okay? No?
So I have a question.
Yes,
So,
Mr. Sinai.
all right, so this can sound like a real dumb question. Kind of that good at
There,
maths,
there
but
are
I'll
no
just
dumb
ask it.
questions.
All right,
Go ahead.
so if sum equals sum plus grade, right? If you put the grade as -1, how come sum is still 0? It wouldn't be -1. So
Sum is equal to sum plus grade only when the grade is greater than or equal to 1 and less than or equal to 100. So if grade was entered as -1, it doesn't fall into this category. Because when grade is -1, is grade greater than or equal to 1? This is false. Is grade less than or equal to 100? This is true. But false and true will give us false, right? When we join these two together, it'll give us false with the and. And as a result, we cannot enter into this set of instructions, which is why we go down here, and this entry was the one that we went down inside there.
all right, yes,
Yeah.
okay.
All right. That clarifies things, right, Jonathan?
Yes, sir.
Right. And I applaud you all. Ask your questions. Don't go on assumptions. Okay, so I don't care how out there the question is going to be, as long as the question related to this. Right? Don't put up your hand and be like, sir, I thinking about something unrelated and you want my advice at this time. All right, so we checking the third set. We're checking the third set of values. Checking the third set of values. Okay. So the third set of values, the first grade, sum and count start off as 0. The first grade is 132. And again, when we enter 132 as our grade, while it's greater than or equal to 1, it's not less than or equal to 100. So this is not going to go into this code here. 132 is not equal to -1. So it's not going to do any of this set of code here. So we will fall into the else and we will print out invalid grade. Okay, mark not recorded. And then the next grade that we entered was -2. We entered -2. And the same thing will happen for -2. -2 is not within this range, so we can't do this first set of code. It's not equal to -1, so we can't do this second set of code. And we get invalid printed again. And then we enter 70. And 70, right, 70 is valid. So sum is now equal to sum plus grade. So sum is now equal to 70. Count is equal to count plus 1. So count goes up to 1. And then we jump to the bottom here and come back around and we enter another grade. And that grade now is our stop value grade, -1. So what happens here? -1 will carry us to this middle piece of code because -1 is not in this criteria here. -1 will carry us to this piece of code, and we say if count is unequal to 0, which it is, average is equal to sum divided by count. 70 divided by 1 is equal to 70, and we print average is 70. Understood? At this point, we jump to the bottom. -1 is unequal to -1 will give us false, and we cannot continue the while.
Sir.
Yeah.
I remember you were saying that you didn't want them to print like please enter grade over and over, but like we are doing that in this program, so maybe we could just put the please enter grade before the do loop, so that the do while they will have it
the
every
location of the please enter grade could change. That's up to the discretion of the programmer, how they want the program to run. Right? But when we get into C, you'll notice that you remember, and this is a rule, remember that users are stupid. Okay? Especially when it comes to programming for a console. So you want to be as verbose as possible. So while you as the programmer, you know the internal workings, please enter grade as an instruction is that's something that you should tell the user to do. Don't, after the first one, if they just see the console hanging and they're waiting for a grade, they might know to enter another grade. Okay? So and I'm not saying it to sound mean, eh? I'm not saying it to sound mean. But you have to assume that people will dotish. Right? So yeah, when that's why this field of computing user experience is now like a big field, because you could think that seems pretty intuitive, and people have they just can't understand where your vision was. Okay. All right. So that's it there for this example. I know that this example seemed a little intense. Yes, go ahead.
Why you put the while loop at the bottom, right? The while grade.
Because we're using the do while structure. So we had to. No, the do while structure doesn't have an end while to it. Okay? The do while structure, yeah, the first instruction is do, and it says what is the block of code that you want to do. And you say do that while this condition holds true, and then you test to see if you should continue.
Yes, sir.
Okay, so I'm going to give you a question to attempt now. This Microsoft Teams control thing at the top of my screen is blocking me from adding a new page. Just hold 1 second, eh? This is annoying.
So this app kind of real slow, so I feel I'm gonna switch to the browser. Really quick.
No problem. So at least now I'm not blocked from. Right, so I'm putting a new page and I'm going to put a question inside here. This question should not be as intense as the previous question, even though it is it's a little longer. Okay? Don't read too much into it. So it says the Last Stop Boutique is having a 5-day sale. Each day, starting on Monday, the price will drop 10% of the previous day's price. For example, if the original price of a product is $20, the sale price on Monday would be $18, 10% less than the original price. On Tuesday, the sale price would be $16.20, 10% less than Monday. On Wednesday, the sale price will be $14.58. On Thursday, it will be $13.12. And on Friday, the sale price would be $11.81. Develop a solution that will calculate the price of an item for each day of the 5 days. You have to use a loop in your solution. I'm saying that because some people just going to, write out a set of statements for me. We have to use a loop in our solution. Understood? Now, let me ask a question just before I let you do this on your own. And I'm going to set a timer for. I feel like 15 minutes is ample time for this. Okay. So, what I just want to know off the bat, what loop will you be using?
So I think in a for loop.
Good. Why would a for loop be appropriate?
Because the way to get the first 5 days. So you go from
Correct.
1 to 5.
Correct. Okay. So thanks. That's just for me to know that we're on the same page. So I'm starting this. And you all have 15 minutes. I'm going to stop the recording.